forth in the solution set according to the lemmas we derived, right? Ooh, look at that. What does this mean? What is it? Y equals to sine theta. What does that tell you about the differential equation? Maybe we shouldn't have this conversation. I won't make this too easy. That's a good question. What's the annihilator for sine theta? We've talked about this. D squared plus 1, right? That means there has to be a d squared plus 1 up in here, right? Because something gave us sine theta, so there must be a d squared plus 1 in here. Otherwise, where did the sine theta come from? Right? Existence and uniqueness theorem says that this has got 4 solutions, so 2 of them are sine and cosine. Right? Where there's sine, cosine's somewhere lurking in the bushes or something, right? It's like it's like a Bannon to the Trump or something. I don't know. It's so whatever you want, but we love the Trump. I did lose my make math grade against Vicar over break. I'm kind of sad about that. Anyway, so my point is you should be able to factor out d squared plus 1 from this. How do you factor d squared plus 1 out from a polynomial?
Synthetic division.
Synthetic division would be fine if it was a linear factor, which is why I don't like synthetic division. But that's a good idea, but that won't, I mean, synthetic division is for x plus 1. So to do synthetic division, I'd have to divide by x plus I, and then again by x minus I. No. Let's not do that, right? So x squared plus 1. So, for example, x to the 4th plus 3x squared plus x minus 7, x squared plus 1. So I have x squared, x to the 4th plus x squared, 2x squared plus x minus 7 plus 2, 2x squared plus 2, x minus 9. Oh, remainder. So apparently, x to the 4th plus 3x squared plus x minus 7 divided by x squared plus 1 is equal to x squared plus 2 plus x minus 9 over x squared plus 1. Check it out. Because there's a remainder, because I just made this up, right? So there's going to be a remainder most likely. And that will not be present in this one if I have not made a mistake. We can easily check, right? I said it's easy to see that that's a solution. Can you see it? Differentiate sine 4 times. What do you got? Sine. Differentiate sine 3 times. What do you got? Negative cosine. This is negative sine. This is 7 cosine. So this and that cancel. This gives us, what did you say? 7 minus 7 sine. So this is sine minus 7 sine plus 6 sine, 0, right? So it looks like I'm okay. So when you do the long division here, it should work out like here. It should work out much nicer. I've told you too much. I'm sorry. I took all the fun out of it. Of course, you should use Wolfram Alpha to check. Yes, no? Yes. Find the general solution of this. Again, you write down the characteristic equation. You go back to our compendium of results, right? Which you should be trying to internalize. There's 3 cases. Distinct roots, repeated roots, complex roots. What do you do in each case? How do you write down the solution? Find the general solution. Oh, look at this. Another adventure in factoring. So here we have a quartic, d to the 4th minus 4d squared minus 5. You should think of d squared as a variable and try to factor it. And then you should try to factor it again, right? This one, I mean, this is a homework, right? So there's some things I might do on a homework that I might not do on a test without, oh, wait a minute. So without this, like this is nice. This makes it a possible test question. Without this hint, it's definitely not a test question because it's factoring and not a little bit unwieldy cubic is really the heart of the problem, right? But what does it say? If this is here, what's that tell you about the operator? It has a d minus 4 in it, so we can factor out a d minus 4 from the d cubed minus 12d squared plus 48d minus 64 acting on y equal to 0 equation. There's a d minus 4 that you can find in there. How about this? Given that x e to the x cosine 3x solves the constant coefficient differential. Oh, I'm just going to have to leave this to you guys. I can't say anything about this. I can't ruin this. This question is important for you to think through. I'm shut up about that. Problem 9. Look at this. So that's got repeated roots. You're going to see, in fact, that e to the x overlaps with the homogeneous solution for this one. On the flip side, x squared does not. So you should end up multiplying the part of the particular solution that corresponds to e to the x by x, but not this one. So your particular solution will have something like ax squared plus bx plus c plus dx e to the x. That should work. You got to work it out, though. Yep.
This may be a strange question, but do you care what variable we use?
Yes.
Okay, so if you ask for x, you want us to put into x.
Right. Right. Attention to detail matters. Yes. 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 Now I will myself fall short of that. You know, standard I'd like to attain, but yes, we do want to. And so I hope I have not given you any now if I have inadvertently given you an ambiguous problem, right, then you can leave it in terms of whatever you like, right? Like you could define a variable like Lady Gaga, and you could give it in terms of you know, exponentials of Lady Gaga if you want. I mean, whatever. Or you could use some other little monster like Pac-Man or something. I don't know, but let's see here. So this is third order. Ooh. Look at that, the triple prime. And then, yeah, there you go, double prime. This one actually is pretty nice. It's got some overlap, but it's not too bad. This one here, again, you should be able to solve. I think this one has got sine 2t, cosine 2t is the homogeneous piece. That does not overlap with this. So you should be able to use for your particular solution something like a e to the t cosine 3t plus b e to the t sine 3t. It's going to be a pain because it's a product rule, right? But you can work it out. So all of these problems have a significant amount of calculation, which you should try to do, because that will help you prepare for what will happen to you on the test, or what won't happen to you if you're ready. Find the minimal annihilator for that. So that's kind of like what we talked about the other day, right? And this solution's interesting. It's got lots of overlap with this function. Oh, look. There's where'd you go? Where's the gentleman who brought up the cosine squared, sine squared? Who was that? Who was that? Is he not here today? He was right there, right? This guy right here. Okay, anyway, so that's his right there. I brought it back. I was trying to think of something more interesting, but that's all I came up with. This right here, you know, basically the badness is the t sine t. You got to think about what kind of particular solution that forces on you. So you work through these examples, you should, at the end of it, have a good sense of how you choose the particular solution. That is the main, most difficult question in this part of the course, figuring out which particular solution you should use. Now, the annihilator method, when you understand it, answers all of those questions at once, right? But you got to get fast, reasonably fast on that question, right? You can't be spending 20 minutes to figure out what the particular solution should be. You need to be able to figure it out in like 5 at the most, right? I mean, this is the main thing that's in front of you to figure out, I think, calculationally. Once you have the particular solution settled, which what the form of it is, you plug it in, you do calculus, you can work it out. If you're careful, you'll get it. If you're not careful, I will take off a little bit, but not too much, as long as you're starting with the right particular solution. You don't start with the right particular solution, it doesn't work for you, I will take off tons of points because it shows to me that you don't know what you're doing. Right? So bad algebra with correct particular solution, pretty good partial credit. Wrong particular solution, correct algebra, doesn't make sense, I don't care. Sorry, but like that's it. Like I want understanding in here. Understanding in here, in particular, is learning how to select the right kind of particular solution. And I've tried to explain, but you know, at some point you got to figure it out. These ones, this is a blast from the past. Now, if I'd put this earlier in the test, you probably would have used the integrating factor method, right? It's a linear first-order differential equation. But I would encourage you to instead think of this as a constant coefficient ODE. So I would construct the homogeneous solution and look for the particular solution that will be easier than the integrating factor method for this problem. All right? So I'm endorsing this idea. Now, you can't always do that, right? If I don't have a 2 here, if I've got a 2 over x, I'm out of luck. I got to do the integrating factor method. I don't got a choice. But if it's constant coefficient, I can use constant coefficient techniques, which are easier. This one is not hard. This one's easier. You might want to start with this and skip the last 6. Just start here. As far as non-homogeneous problems go, this one's actually very nice. This one is also, and so here's the idea here, guys. I don't know, when you watched the video, did I talk about superposition in that video? I would like you to read the notes. In the notes, I talk about superposition. It is something you should know about and be able to use. If you study my previous tests, you'll see I usually have a trifecta of questions that is superposition based. I'm like, solve this problem, solve this problem, solve this problem. The third problem requires no work if you know superposition. This one's not exactly that, but it's kind of related to that. So here I have the same differential equation, the homogeneous piece. See that? Here I've got x squared, here I've got 3x squared, right? So I don't actually have to treat the 3x squared down here. I can solve it for sine x. And then I can take 3 times the solution for this one, the particular piece of it, and add it down here. That will be the particular solution. This is the superposition principle. You can add particular solutions properly weighted of related problems. Look it up, principle of superposition. It's in the notes. There are examples. Everything I've talked about so far has been undetermined coefficients or the homogeneous problem for constant coefficients, right? Finally, something else. This one, e to the 2x over x. This is my token variation of parameters problem for you guys, all right? Don't read too much into this. This doesn't mean that I'm not testing variation of parameters. It just means I didn't want to assign you 5 of them because they take a bunch of time and they're not that interesting. So 1 should be enough for you to get the idea of it. Really should. Okay, so it's important that you do this problem. This is variation of parameters, see, because that's not in the homogeneous solution set for any constant coefficient ODE, right? So you got to do variation of parameters on this one. Problem 18, well, this is a vacation from life, right? You calculate the Wronskian of this thing, you show it's non-zero. Done. It's 2 by 2. Find the integral curves to the vector field. So I would refer you to the lecture where we talked about that. Find the orthogonal trajectories to the curves in the previous problem. I would refer you to our previous conversations about orthogonal trajectories. These, I think, are interesting. This guy. So now I put the first order stuff at the end of the test because, I don't know, I just think it's more important for you to have the nth order stuff really pinned down. A lot of the first order stuff you can figure out without as much studying, right? It's pretty much you just integrate, like a lot of it. You need to study it, right? But I think there's much more potential for catastrophic failure in the nth order materials, my past experience with students. This one, what do you guys want to? What do you want to guess? What method should you think about here? It looks like it's probably an exact equation, right? Yes, yeah. This one here, I have the force of frictions minus alpha v cubed. That's the net force. So you find the velocity as function of time and velocity as function of position. We did that back in the applications day. I think for square, do we have a v squared instead of v cubed? Please tell me I didn't actually do this one in class.
I think you do squared.
Okay, phew. Good. I made up this question about kids drinking Kool-Aid. I'm somewhat proud of it. I'll let you look at it. It's not that hard. In problem 24 and problem 25, here is your token operator question, x squared plus d, x squared d squared minus 1. I want you to calculate L1, L2 versus L2, L1. See how they're different. And then I want you to solve L1, L2, y equal to 0 by making a z equals Ly2 substitution. If you do that, right, if you put z equals to Ly2, what does this become? This becomes L1 of z equal to 0. So if you look at what L1 is up here, you're solving x squared times z plus dz dt, I suppose. I didn't tell you what the d is, did I? Let's make this d. What do you guys want to make it? Oh, actually, it's implicit here, isn't it? It's ddx. I'm an idiot. So ddx. So if you follow this, you can solve it. There is an example like this in the notes, which is much worse. And I'll shut up. I'll shut up, I promise. If you look at my notes, though, I do have an example like that. We didn't cover it in class before. And this doesn't get taught as much as maybe it should. Or maybe it's taught just enough. Like, I think you should be aware of it. But it's really difficult to implement. But this example 7.3.1, here I have L1 is x ddx and L2 is 1 plus ddx. And I solve L1, L2 equal to 3 by making just such a substitution. I call z equal to the inside thing, and then I solve the outside equation. And then anyway, so this example is a harder version of like 24. And I actually show that L1, L2 is a different equation than L2, L1. They give different differential equations because the operators don't commute. So anyway, I shall shut up. I'll see you when? Oh, Thursday, right? I guess we should talk about the solutions to the quiz. Is that good?
That's probably a good idea.
We want to do it now?
That means I got to solve this before Thursday? Oh, man.